in traditional software engineering, I mean, a green check mark means your code works, right? You
Sure.
write a unit test, you run the test, and if you see green, you just deploy. It is binary, it's comforting, and it's totally deterministic. But in the world of AI development, that green check mark is basically a complete lie.
Oh, absolutely. It's an illusion.
Yeah, exactly. So welcome to the late night studio. If you are staring at a dark IDE theme right now, stepping out of the comfortable world of traditional code and plunging into the unpredictable, non-deterministic waters of large language models, well, this deep dive is dialed in specifically for you. Tonight, our mission is to unpack the really messy reality of AI evaluation. We're looking at why the ultimate, irreplaceable gold standard for knowing if your LLM is actually doing its job is not a script, not a test suite, but an actual human being.
And, the transition from traditional software to AI is jarring for exactly that reason. When engineers first move into machine learning, their immediate instinct is to look for the automated metric. I mean, they want a script, something they can just run in a CI pipeline that mathematically proves the AI output is quote-unquote correct.
Right, because that's what we're trained to do.
Exactly. But the reality we're looking at in our sources today is that automated metrics for language generation just fall incredibly short. They completely miss the nuance, the context, and the subjective quality of what the model is generating. An automated metric is just measuring a proxy. It is not measuring the thing itself.
Let's ground that in reality for a second. If I write, say, a Python function to sort an array, I can write a script to check if the output array is actually sorted. That is not a proxy. That is just the actual definition of success.
Yes, exactly.
Yeah. But if I ask an LLM to summarize this angry customer email professionally, how does an automated metric even begin to evaluate that? Structurally speaking, it seems like it just counts things, like it might check if certain keywords from the original email are present or measure the length of the response.
Precisely. Historically, the field relied heavily on metrics like BLU or Rouge, which fundamentally just look for n-gram overlap.
Right, just matching chunks of text.
Yeah, they check if the generated text uses the same chunks of words as a human-written reference text. But language is infinitely complex. Two sentences can have the exact same keywords, but mean completely opposite things because of, a subtle shift in tone, a misplaced comma, or a tiny bit of sarcasm.
So the automated metric says, yes, a 90% word match, green check mark, while the actual output is this technically accurate but wildly passive-aggressive email that is just going to infuriate the customer even more.
Exactly. The metric cannot measure passive-aggressive. It cannot measure helpfulness. A human being inherently understands that unwritten context. A human understands the difference between a technically accurate answer that is completely useless and a slightly less precise answer that perfectly solves the user's problem.
Which a script just misses entirely.
Right. We simply cannot script that understanding yet. If you want to evaluate vibes, tone, and actual utility, well, human evaluation remains totally irreplaceable. You have to capture human judgment.
But wait, you just said language is infinitely complex and humans are subjective. If I am an engineer trying to build a data set out of human opinions, that subjectivity is a nightmare. I want clean data. So if human evaluation is mandatory, how do we actually extract a reliable signal from a messy, inconsistent person?
It's a huge challenge, yeah.
Because my first instinct, and I bet the instinct of anyone listening who has ever built a customer feedback form, is to just show a human the AI's output and say, hey, rate this on a scale of 1 to 10.
It is the most natural instinct in the world, and it is entirely wrong for AI evaluation.
Oh, well, entirely wrong.
Yeah, what you are describing is a Likert scale, and the research shows it is a terrible way to capture high-quality human judgment for language models.
Okay, let's unpack this. Let's think about why that fails from a cognitive perspective. If I ask you right now to rate a specific API's documentation on a scale of 1 to 5, what happens in your brain?
Complete cognitive freeze. I mean, I immediately start overthinking the anchor points of the scale. I might think, well, the endpoints are listed clearly, so it is at least a 3. But the code examples are in an older version of Python, so do I dock a point? Is a 4 too generous because there is no dark mode?
Right. You are spending significantly more cognitive energy trying to define what an abstract 4 even means than you are evaluating the actual documentation itself. And worse, my definition of a 4 is definitely different from your definition of a 4. I might be a harsh grader who never gives 5s, and you might just hand them out like candy.
In cognitive psychology, this is known as absolute calibration. Humans have terrible absolute calibration. When you ask a human to provide an absolute score, you are asking them to anchor their judgment to a standard that does not objectively exist.
Because the standard is just made up in their head.
Exactly. But if we shift the paradigm, what if, instead of asking for a score, you put two different versions of that API documentation side by side, version A and version B, and simply ask which one is better?
Ah, well, the answer is instant. I look at it and say version B. The font is easier to read, and the examples use Python 3. Boom, done. No agonizing over whether it's a 4 or a 5.
And that right there is why the sources reveal that pairwise comparison is the absolute bedrock of modern AI evaluation. Humans have terrible absolute calibration, but we possess incredible relative discrimination.
That makes so much sense.
Yeah, from an evolutionary standpoint, we are wired to look at two things and instantly decide which one is bigger, which one is faster, which one is safer. We are relative comparison machines.
So, applied to LLMs, instead of showing an evaluator one response and asking, is this an 8 out of 10? We run the prompt through two different versions of our model, or maybe our model and a competitor's model, and ask the human, did response A or response B answer the prompt better?
Exactly. When you use pairwise comparisons, the cognitive load on your human evaluators drops massively. They work faster, they experience less fatigue, and most importantly, their judgments become vastly more consistent.
Because they aren't fighting the scale anymore.
Right. You strip away the noise of them trying to calibrate their personal scoring scale, and you isolate the actual signal, which is the relative quality of the AI's output. If you do this thousands of times across multiple prompts, you are essentially building an ELO rating system for your AI, exactly like they use to rank chess players.
I love that framing. It is an ELO ranking for text. But let's push into the next bottleneck here. Even with A versus B, humans are still going to clash, right? Say we are evaluating a summarization task.
Yeah.
I look at response A and response B, and I think A is clearly better because it is incredibly concise.
Yeah.
But you look at the exact same two responses, and you say B is better because it retained a specific nuanced detail. We have used pairwise comparison, but we still have a collision. How do we trust the data set if the humans building it literally cannot agree?
This is a scenario that happens constantly. When you have multiple human evaluators, often called annotators, you will inevitably encounter disagreement.
So what do we do?
Well, the amateur move is to just take the majority vote and ignore the friction. The professional move is to quantify that friction. This is where the concept of inter-annotator agreement comes into play.
Okay, let's get into the mechanics of that. The sources specifically highlight metrics like Cohen's Kappa or Fleiss Kappa. How do these actually work? Because if it just measures the percentage of times we agree, that seems flawed. Like, if we were just choosing between A and B, we could just be flipping a coin and we would agree 50% of the time by pure random chance.
You hit the nail on the head. That is exactly why simple percentage agreement is a highly dangerous metric. What Cohen's Kappa does is mathematically subtract that baseline of random chance.
Oh, interesting.
Yeah, imagine you and I are evaluating 100 prompt responses. If we just guess randomly, probability dictates we will agree 50 times. So if we actually agree 60 times out of 100, our true agreement isn't 60%. Our true agreement above random chance is actually quite low.
Because 50 of those were just luck.
Exactly.
Yeah.
Cohen's Kappa calculates that true signal of alignment. It gives you a score from -1 to 1, where 1 is perfect agreement, 0 is random chance, and anything below 0 means we are actively disagreeing more than chance would even predict.
So it completely filters out the lucky guesses.
Yeah.
That is brilliant. It gives you a rigorous mathematical score. But I want to explore how developers actually react to that score. Because if I am an engineer and I have spent weeks fine-tuning an LLM and I hand the outputs over to human evaluators and the Kappa score comes back at a dismal 0.2, I mean, my immediate defensive instinct is going to be to blame someone else.
Naturally.
I am going to assume the annotators are lazy and just clicking randomly. Or I'm going to assume my model is outputting such confusing garbage that nobody even knows how to read it.
That is the most common pitfall in AI development. The instinct is to blame the model's intelligence or the annotator's competence. But the sources are very clear on this. 9 times out of 10, the problem is neither of those things.
Let me draw a parallel to traditional software product management here. Have you ever worked on a team where two different engineers are handed the exact same JIRA ticket, they go off to their desks, and a week later they come back having built two completely different features?
Oh, many times. It is a classic painful software engineering nightmare.
Right. And when that happens, the problem is almost never that the engineers forgot how to write code. The problem is that the acceptance criteria in the JIRA ticket were vague. The requirements were muddy. The product manager wrote, "Make it user-friendly." And one engineer interpreted that as add more tooltips, while the other interpreted it as remove half the buttons. It sounds like AI evaluation has this exact same dynamic.
That analogy is absolutely perfect. If your inter-annotator agreement is low, if your Kappa score is in the basement, the problem is almost definitively in your guidelines. It means your acceptance criteria for what makes a good AI response are just too vague.
So going back to our earlier collision where I picked response A for being concise and you picked response B for being detailed, the problem wasn't that one of us was quote-unquote wrong. The problem was that the evaluation rubric didn't explicitly state whether the priority for this specific task was brevity or comprehensiveness.
Exactly. You shouldn't look at a Kappa score as just a math formula you run at the end of a project to report to your manager. It is a diagnostic tool. It is a quality thermometer for your baseline truth.
Quality thermometer, I like that.
Yeah, a low Kappa score is a blaring alarm that you need to rewrite your evaluation rubrics. You need to provide better examples, clear edge cases, and much tighter definitions of success to your annotators. You have to remove the subjectivity from the human task as much as mathematically possible before you can even trust the data. Think about it. If human beings cannot agree on what good looks like, how can you possibly expect a neural network to learn it?
Okay, that makes total sense. So let's imagine we have done the hard work. We're using pairwise comparisons to leverage relative discrimination. We have relentlessly refined our guidelines so our Cohen's Kappa is through the roof. We have isolated the pure signal of human judgment. If this human evaluation is the undisputed gold standard, the ultimate ground truth, well, why don't we just use it for everything?
I wish we could.
Right. Like, why don't we have a human review every single code commit, every single prompt tweak, every single parameter adjustment in the model?
The answer to that comes down to the most brutal reality in all of engineering, which is cold, hard cash. And just the sheer physics of scaling. Human judgment is incredibly expensive. Depending on the complexity of the domain, the sources note that a single human judgment, one A versus B comparison, can cost anywhere from 10 cents to well over $100.
Wait, pause. Over $100 for one single A versus B comparison. How is that even possible?
Think about the specific domain you are evaluating. If you are building an LLM that summarizes celebrity gossip articles, sure, you can pay a general crowd worker 10 cents to tell you if the summary is accurate. But if you were doing domain-specific reinforcement, learning from human feedback, say, evaluating an LLM designed to synthesize complex oncology research, or an AI drafting bespoke corporate merger contracts, you cannot give that to a random person on the internet.
Right, because I wouldn't even know what I was looking at. A random crowd worker can't tell you if a medical summary hallucinated a really subtle drug interaction.
Precisely. You need a board-certified oncologist or a specialized corporate attorney to do the evaluation. Their time bills at hundreds of dollars an hour. And you don't just need one judgment. You need thousands or tens of thousands of these pairwise comparisons to generate enough data to meaningfully fine-tune a model.
Wow.
Yeah, $100 a pop will vaporize an entire startup seed funding in an afternoon. Human evaluation is the gold standard, but it is literally priced like gold.
So AI teams are forced into a corner. You absolutely need the human nuance, but you completely lack the budget to use it continuously. So what does this mean for the actual architecture of an AI project? It sounds like we need to build something analogous to a modern CI/CD pipeline.
How do you mean?
Well, in a continuous integration pipeline, you have different layers of testing based on speed and cost, right? At the lowest level, you have your linters and basic unit tests. They are cheap. They run in milliseconds. You run them every single time a developer hits save. They aren't catching deep logical flaws, but they catch syntax errors and keep the iteration loop moving really fast.
Right, the fast feedback loop.
Exactly. But for major milestone decisions like a massive release candidate going to production, you don't just rely on the linter. You bring in the expensive manual QA team to do exploratory testing. It sounds like AI evaluation requires that exact same tiered approach.
That is the exact blueprint the sources detail. The most effective AI evaluation systems use a layered architecture. Think of it as a pyramid. At the very bottom, the widest layer, you have your automated filters and heuristic metrics.
The linters.
Yes. These are cheap, they are lightning fast, and they run continuously during development. They might just be checking for formatting, ensuring the output is valid JSON, or running a blocklist check for banned words.
The AI linters, basically.
Exactly. But then you step up to the middle layer of the pyramid. This is the bridge between cheap scripts and expensive humans. This is where you find reward models.
Okay, let's really dig into the mechanics here. I hear the term reward model thrown around constantly in discussions about RLHF, but what exactly is it doing? How does it actually work?
A reward model is a secondary AI model that has been specifically trained to predict human preferences. It acts as a proxy evaluator. It takes the main LLM's output, analyzes it, and outputs a scalar reward, basically a mathematical score that represents how much a human would like that response.
Wait, how does it know what a human likes? How do you train a model to output a mathematical score for, like, vibes?
You use that ELO ranking data we talked about earlier. You take the highly expensive, perfectly calibrated data set of pairwise comparisons generated by your doctors or lawyers. You feed that data into this secondary neural network.
Oh, I see.
The network analyzes the patterns. It notices that humans consistently prefer the responses that are structured a certain way or that avoid certain passive-aggressive phrasing. It learns the underlying logic of human preference. It is essentially a compression algorithm for human taste.
A compression algorithm for taste. That is wild.
Yeah, it is slower and more computationally expensive than a basic script, but it is infinitely cheaper and faster than hiring actual humans.
Okay, so we have automated heuristic filters at the bottom, the taste embedding reward models in the middle, and then the top layer is.
The top layer is your human experts, the expensive, slow, but incredibly accurate gold standard.
I see the structure, but here is my question. If the humans are just sitting at the very top of the pyramid doing periodic milestone checks, how does their expertise actually improve the day-to-day engineering happening at the bottom?
This is where the entire system comes alive. The magic of this layered architecture doesn't just come from filtering bad outputs at different stages. The magic happens because each layer calibrates the layer below it. The flow of knowledge moves downward.
Okay, walk me through that downward cascade.
The human experts at the top generate a relatively small but flawlessly accurate data set of pairwise comparisons. You use that perfect data set to train and fine-tune the reward model in the middle layer. You are literally transferring the human's nuanced judgment into the reward model's weights. Then, that highly calibrated reward model is used to continuously score and tune the main LLM during its fast daily training loops. Furthermore, you can even use the reward model to evaluate and improve the cheap heuristic filters at the very bottom.
That is fascinating. The humans aren't just acting as a final QA gatekeeper. They are actively teaching the automated systems how to be better proxies. They use their $100 judgments not to grade every single code commit, but to build an automated proxy that is finally sophisticated enough to trust. You spend your money where it has the absolute highest leverage.
Exactly. It is the only mathematical and economic way to scale AI evaluation without compromising the nuanced understanding that only human beings possess.
If we step back and look at the journey we have taken tonight, it really demands a complete mental reset for any software engineer moving into this space. You have to accept that writing unit tests for language generation is a fool's errand. You have to embrace the psychology of judgment, completely abandoning those paralyzing 1 to 10 Likert scales in favor of the rapid-fire relative discrimination of A versus B pairwise comparisons.
And you have to embrace the friction of human disagreement rather than hiding from it.
Yes, instead of getting defensive when evaluators clash, you use Cohen's Kappa as a diagnostic thermometer to fix your own vague JIRA tickets, your guidelines. And finally, you have to architect this multi-layered pipeline. Fast automated filters governed by taste-predicting reward models, which are ultimately calibrated by the expensive gold standard of human experts. It's a completely different engineering paradigm.
It is a massive structural shift. And the truth is, we have really only covered one half of the AI lifecycle tonight.
Right.
Because everything we have discussed so far, the pairwise comparisons, the kappas, the reward models, is entirely focused on measuring quality. It is about defining what good looks like and ensuring the model consistently hits that target. But tomorrow, we're going to take this deep dive into much darker territory.
Oh, I know what is next on the outline, and it is easily the most exciting part of the development process.
Tomorrow, we shift from measuring quality to actively hunting for catastrophic failures. We're going to explore the world of red teaming. We will look at how you stop testing for success and start thinking like a malicious attacker. How do you systematically try to break your own AI? How do you find the hidden vulnerabilities, the prompt injections, and the breaking points before your users ever get a chance to exploit them?
It is essentially state-sanctioned hacking against your own product. I cannot wait to dig into that. But as we wrap up tonight's late night session, I want to leave you, the listener, with a final lingering thought to mull over while your build fish is compiling. We just talked about this beautiful layered pyramid The highly expensive human experts at the top are constantly pouring their nuance into the automated reward models in the middle. The humans are literally teaching the AI how to judge like a human. So here's the question you have to ask yourself as we look toward the horizon of this technology. If that downward cascade of calibration continues indefinitely, at what point does that automated AI-driven proxy become so deeply infused with human preference, so perfectly calibrated, that it becomes functionally indistinguishable from the human gold standard itself? And when that day inevitably arrives, and the reward model is just as good as the doctor or the lawyer who is evaluating who, keep building, keep questioning the green check marks, and we will see you on the next deep dive.